Nuclear-powered missile submarines became a key part of Western and Soviet deterrence.
The cameras were already rolling when the remotely operated vehicle slipped through the jagged tear in the submarine's hull and drifted into the darkness of the forward compartment. For hours, the team had been mapping the outside of the wreck, tracing the rusted silhouette of a Soviet attack submarine that had vanished at the height of the Cold War. The ocean had claimed its steel and its secrets decades ago, or so everyone thought, yet as the vehicle's lights cut through the black water, the scientists on the surface knew they were looking at something far more intact and mysterious than a simple relic of a past arms race. Before we start, hit the like and subscribe buttons for more exclusive news. The expectations had been modest at first. The mission, funded by a coalition of oceanographic institutes and historical foundations, was officially about studying corrosion, deep-sea ecosystems, and the structural integrity of old wrecks. Submarines were ideal laboratories for that kind of work. Their sealed hulls could trap microenvironments, preserve sensitive instruments, even shelter unknown organisms. The Soviet designs, in particular, were notorious for the secrecy surrounding their construction, making every discovered wreck a rare window into the engineering mind of a vanished state. No one on the expedition expected that when they eased the vehicle inside, the instruments would begin to register patterns that made no sense, either as engineering or as natural phenomena. As the ROV's lights swept across the interior, the first surprise was how much of the compartment had resisted collapse. A tangle of cables, machinery, and bulkheads remained frozen in place, as if the crew had fled only yesterday. But the real anomaly pulsed from deeper within the wreck. Sensors mounted on the vehicle began to register faint electromagnetic fluctuations, rhythmic and organized. At this depth, in a hull that had been resting on the seabed for decades, there should have been only the steady background noise of the deep ocean. Instead, the instruments recorded patterned pulses like a heartbeat buried under layers of steel and sediment. Following the signal, the pilots guided the vehicle toward a bulkhead that the team had assumed was a simple internal wall. As the cameras approached, details emerged that made the scientists lean closer to their monitors. The surface of the bulkhead was overlaid with a lattice of unfamiliar material, something that had not corroded, not flaked away, not even discolored with the years. Between the strands of this lattice lay small, regular modules embedded in the metal, aligned in geometric precision. It looked nothing like standard Soviet naval engineering from available blueprints. It seemed, instead, like an extra layer of structure grafted onto the submarine from the inside, an augmentation invisible from outside scans. A second vehicle, equipped with more delicate manipulators, was sent in. Carefully, it brushed away, the fine silt hovering in the water, revealing symbols etched into the metal near the lattice. The markings were not typical Cyrillic labeling, not standard maintenance codes. They had the look of internal project designations, but arranged in patterns that suggested a secondary meaning, something more than simple labels. The electromagnetic pulses strengthened as the manipulator neared the lattice, as though proximity awakened a dormant response. Yet there were no active power sources on the submarine. Its reactor was long shut down, its batteries dead, its cables severed by time and pressure. At the surface, the lead physicist watched the readouts with a growing sense of unease. The pulses were weak but ordered, forming sequences that did not match any known natural background signal. Nor did they behave like conventional electronics, which should have fallen silent decades earlier. The team began to suspect that the lattice was not merely a structural reinforcement, but an integrated device. Perhaps an experimental system the Soviets had built into select submarines. An answer to a question no one had known they were asking. The more data they collected, the clearer it became that this was not a simple relic of obsolete technology, but a window into an entire field of research the world had never officially acknowledged. Within hours, the discovery changed the tone of the mission. What had been a slow, methodical expedition shifted into a delicate race against time, not because the wreck was in immediate danger, but because the significance of the find meant that every observation, every sample, had to be documented with painstaking care. The lattice appeared to be bonded at a molecular level to the bulkhead, neither welded nor simply bolted on. It behaved as though it were part of the metal itself, yet distinct enough to generate signals and interact with its environment. That alone challenged conventional ideas about materials science of the Cold War era. It suggested that somewhere within the Soviet research apparatus, a team had been exploring forms of matter and energy control far ahead of what public histories had ever recorded. As more compartments were explored, similar lattices appeared in key locations, near the control room, along the missile storage section, and around what appeared to be a specially shielded chamber that did not correspond to any known design for this class of submarine. The chamber was the real revelation. Its walls were lined with the same uncorroded material, forming a kind of cage within the hull. Inside, suspended in the stagnant water, were fragments of devices that had shattered when the submarine sank. Even broken, they retained an eerie symmetry. Each component was shaped to interlock with others, forming a configuration the engineers on the team could only describe as a three-dimensional circuit, not laid flat on a board, but woven through space itself. The implications rippled through every discipline represented on the ship. For historians, the discovery hinted at secret programs that might rewrite the narrative of the technological competition between superpowers. If the Soviets had been experimenting with such advanced materials and three-dimensional circuitry in operational submarines, then entire chapters of Cold War research had occurred in the shadows without leaving clear traces in declassified documents. For physicists, the persistent electromagnetic patterns raised questions about how energy could be stored, channeled, or stabilized over decades without a conventional power source. For engineers and materials scientists, the uncorroded lattice acted like an accusation, a reminder that their understanding of corrosion, bonding, and structural endurance might be incomplete. The absence of obvious power generation invited intriguing hypotheses. Some suggested that the lattice might interact subtly with the surrounding environment, harvesting minuscule gradients in temperature, pressure, or electromagnetic background noise, and converting them into usable energy. Not enough to drive engines or lights, but sufficient to maintain a stable internal state. Others proposed that the patterns being recorded were the fading echo of processes that had been more active while the submarine was still operational. In that case, the wreck represented a frozen snapshot of a technology mid-function, as if a complex experiment had been interrupted and then preserved in the cold depths before anyone could dismantle or erase it. Because the design was so deeply integrated into the submarine structure, the find also challenged traditional views on military innovation. Rather than being an isolated prototype locked in a laboratory, the system had been carried into the most perilous operational environment, the deep ocean, during a period of extreme geopolitical tension. That fact alone implied a level of confidence or desperation that raised further questions. Had this technology been meant as a strategic advantage, perhaps allowing submarines to operate more silently, resist detection, or manage their onboard systems in entirely new ways? Or had the submarine itself been a testbed, a moving laboratory slipping beneath the waves to shield its secrets from prying eyes above? The event did more than open a historical mystery. It illuminated the extent to which the oceans still conceal experiments and technologies from past generations. For decades, the assumption had been that most classified innovations from the Cold War had either been disclosed, superseded, or lost in archives. The Soviet wrecks were cataloged as dangerous but technically understandable objects, carrying familiar reactors, torpedoes, and sonar systems. The newly discovered lattice showed that these assumptions were too comfortable. It demonstrated that the sea can hide not just wreckage, but entire research trajectories, preserved in pressure and darkness until science advances enough to recognize their significance. In practical terms, the discovery forced scientists to rethink how they approach deep-sea exploration. No longer could they treat wrecks purely as archaeological sites or artificial reefs. Every pass with a sensor, every scan of a hull, might reveal layered structures or energy signatures that point to forgotten projects. This does not merely expand the list of things to look for. It shifts the philosophy of exploration itself. The ocean becomes a library of unfinished experiments and unspoken ideas, where steel hulls and secret compartments are as meaningful as coral formations and hydrothermal vents. With each survey, researchers must remain alert not only to natural wonders, but to technological ghosts. At the same time, the lattice offered a tantalizing glimpse of what future engineering might learn from past secrecy. Although the full function of the system remained unclear, certain features were unmistakable. The material resisted corrosion in an environment that destroys nearly everything over time. It maintained structural cohesion under immense pressure, and it continued to interact in some subtle way with surrounding fields and currents, hinting at passive energy management. Each of these properties has immediate relevance to modern challenges, from building long-lasting infrastructure in extreme environments to designing low-energy devices that can operate for decades without maintenance. There is also a quieter, more philosophical implication. The discovery inside the Soviet submarine underscores how incomplete our understanding of recent history can be, even when dealing with a period as heavily studied as the Cold War. The narrative that dominates textbooks and documentaries often focuses on missiles, summits, and crises visible on the surface of international relations. Yet beneath that visible layer lies a submerged continent of classified research, experimental systems, and half-forgotten prototypes. The lattice in the wreck is a physical reminder that history is not just written in archives and memoirs, but in the hardware lying on the seabed, silently transmitting questions to those who know how to listen. For the scientific community, the event encourages a more interdisciplinary approach to such finds. No single field can claim ownership over a discovery that blends materials, science, physics, history, engineering, and even aspects of cryptography, given the unusual markings and patterns on the structures. Specialists must collaborate, sharing perspectives that rarely intersect in conventional academic life. Oceanographers interpreting sonar patterns might find themselves working alongside linguists who study technical nomenclature, or ethicists who consider how to handle sensitive information that emerges from long-buried military programs. The submarine becomes a meeting point where disciplines converge, each offering a different lens through which to decode what lies within. Another implication lies in the realm of transparency and secrecy today. Learning that a former superpower embedded such sophisticated, undocumented systems in its submarines inevitably raises questions about the present. If that level of clandestine research could take place decades ago, how much more advanced and concealed might contemporary programs be? The wreck inadvertently becomes a benchmark. It shows that the boundary between known and unknown technologies is more porous than many assume. This awareness can influence how scientists interpret unusual data in current observations, encouraging them not to dismiss odd readings as mere noise, but to consider whether they may be glimpsing the footprints of hidden human activity. The event also reshapes expectations about what future expeditions might uncover. Every Soviet wreck, every lost submarine from any nation, suddenly feels less like a closed chapter and more like an unopened book. Institutions that once saw such expeditions as primarily historical or environmental may now recognize them as opportunities to encounter entirely new approaches to problems that are still current. Since the lattice reveals a way of thinking about structure and energy that does not map neatly onto contemporary design paradigms, it suggests that other wrecks might hide other conceptual breakthroughs. Ideas abandoned not because they failed, but because history moved on before they could be fully explored. Beyond policy and research agendas, there is an impact on how humanity imagines the ocean itself. The deep sea has always evoked mystery, but largely in terms of unknown species and unexplored trenches. Now the mystery acquires a more human dimension. The seafloor is not just home to strange creatures and geological wonders. It is also a repository of human ambition, fear, and ingenuity, preserved in steel and alloy. The Soviet submarine, resting quietly in the dark, transformed from a mere wreck into a kind of time capsule, containing echoes of conversations in secret design bureaus and unrecorded debates in classified meetings. Even without knowing their exact words, one can sense the intensity of the effort encapsulated by that lattice. As scientists continue to analyze the data gathered from inside the wreck, the discovery encourages a more humble attitude toward the past. It is easy to view previous decades as technologically simpler, their limits well understood. The lattice undermines that complacency. It suggests that entire avenues of research may have been pursued and then buried by political change, institutional collapse, or simple loss of continuity. Recovering those ideas is not about glorifying old regimes or their military projects. It is about recognizing that innovation does not follow a single straight line toward the present. Instead, it branches, doubles back, and sometimes disappears into the depths, waiting to be rediscovered. The longer the team studied the data, the more it became clear that the real transformation was not confined to one wreck or one technology. Minds began to shift. Marine expeditions that had once been treated as niche, slow-moving projects suddenly found themselves at the center of a new intellectual current. Funding bodies previously hesitant to support long campaigns at sea started to see the abyss not just as a scientific curiosity, but as a reservoir of unsampled human knowledge. The submarine's interior had moved the deep ocean into the category of places where entirely new ideas might be waiting. Back on land, the laboratories receiving samples and high-resolution scans had to adapt just as quickly. Specialists who were accustomed to dealing with conventional alloys and electronics faced something that did not fit into standard workflows. Instruments had to be recalibrated to capture delicately structured fields and microscopic patterns in the retrieved fragments. New protocols emerged for handling artifacts whose behavior was not fully understood. Simply placing a piece of material on a bench and measuring it no longer felt sufficient when its original environment included crushing pressure, near-freezing temperatures, and an electromagnetic context that standard test rooms could not reproduce. The event began to influence how institutions train the next generation of researchers. Universities that once treated ocean technology and Cold War history as separate electives started to weave them together. Students in physics seminars found themselves studying not only abstract theories, but also the practical implications of a submarine compartment designed around unfamiliar principles. Courses in maritime archaeology grew more technical, emphasizing not just the recovery of objects, but the ability to recognize when an artifact hints at an unfamiliar underlying science. The wreck had, in effect, become an unplanned case study in how to interpret discoveries that straddle multiple disciplines. Geopolitically, the implications were delicate. Even though the submarine belonged to a state that no longer existed in its original form, the legacy of its designs still carried national pride, unresolved secrets, and legal questions about ownership. Diplomatic channels that usually concern themselves with territorial waters and fishing rights now had to quietly address what it means when a long-lost military platform contains elements that may inspire entirely new technologies. There was no public confrontation, no dramatic standoff at sea, but behind closed doors, policymakers were forced to update their mental maps. The seafloor no longer seemed like a simple graveyard of obsolete hardware. It had to be considered a strategic archive. The discovery also touched on deeper ethical questions about how to treat such sites. A submarine wreck is not just machinery, it is also, in many cases, a tomb. The exploration that led to the revelation had been conducted with respect for that fact, but the sudden recognition of scientific value sharpened the dilemma. How far should researchers go in dismantling or probing a structure that may hold human remains, even if the information inside could benefit countless people in the future? Codes of conduct, once focused mainly on avoiding looting or sensationalism, now had to grapple with the tension between honoring loss and advancing knowledge. Public imagination, meanwhile, responded in its own way. The notion that the deep sea hides not just strange organisms, but also forgotten inventions ignited a new flavor of fascination. Documentaries, novels, and speculative discussions began to highlight the idea that technological history might be patterned like a seafloor itself, with obvious ridges and peaks representing well-known breakthroughs and vast flat plains concealing subtle, overlooked ridges of creativity. The submarine became a symbol of that unseen terrain, a reminder that the boundary between reality and near fiction is sometimes just a matter of what has been recovered. On the practical side of exploration, the incident encouraged engineers to redesign their tools. Remotely operated vehicles that once prioritized durability and basic imaging began to incorporate more sophisticated sensor suites, capable of detecting faint anomalies in fields and forces rather than just physical shapes. Navigation software was upgraded to let pilots linger intelligently where unusual readings appeared, instead of treating such locations as noise to be filtered out. Future missions would not only map hulls and debris, but also scan them for invisible patterns that might betray embedded systems or unusual interactions with the environment. The event even influenced how archives and declassified documents were read. Historians returned to obscure technical memos, ambiguous budget lines, and cryptic meeting notes that had previously seemed unremarkable. Small references to experimental units, odd procurement codes, or unnamed special compartments now carried different weight. The wreck had shown that ambitious projects might leave only the faintest of textual traces, while their main evidence lay rusting in the dark. To piece together the fuller story, Researchers had to treat the ocean and the archive as a single dispersed record, each illuminating gaps in the other. If you like this video, please give it a like and subscribe to our channel. Also, could you leave your comments below and tell us, what are your thoughts on discoveries inside the Soviet submarine wrecks? We want to hear from you. Thank you for watching and see you next time.